Hello everyone. In this lesson, I'll complete part 3 from the ministerial question of finding limits numerically. We reach number 52. Find the limit of cosine x when x approach to pi. When x approach to pi, it is cosine pi. Cosine pi is, as you know, this is pi. Cosine pi is -1. Choice B. 53. Find the limit of sine 2x over x when x approach to pi. Substitute every x with pi directly, then the limit will be sine 2 pi over pi equal to sine 2 pi, it is 0. This is 2 pi. Sine 2 pi is 0. 0 over pi equals 0. Choice B. 54. Find the limit when x approach to pi over 2 for x sine x. Substitute directly every x with pi over 2, then it will be pi over 2 sine pi over 2. Sine pi over 2 is 1. Then the answer is pi over 2. Choice A. Question number 55. Find limit of x cosine x when x approach to pi. Directly substitute every x with pi. The answer will be pi cosine pi. Cosine pi is -1. Then the answer is -5. Choice D. 56. Find the limit when x approach to 0 to sine 3x over x. When x approach to 0, then think to make the function sine 3x over 3x. Then I multiply by 3 and divide by 3. 1 over 3, 3 limit x approach 0 sine 3x over 3x. I multiply by 3 and divide by 3. This limit is 1. 3 times 1 equals 3. The right choice is C. 57. Find the limit when x approach to 0 to 3 tan 5x over 5x equal to 3 limit tan 5x over 5x when x approach 0. This limit is 1. Then 3 times 1 equal 3. Choice B. Question number 58. Limit x approach to 0 to tan square x over 2x. We know that limit x approach to 0 to tan square x over x is 0. Then I can rewrite this limit as 1/2 limit, since 2 is constant, x approach to 0 tan square x over x. This limit is 0. 0 times half 0. The right choice is C. 59. Limit x approach 0. 1 minus cosine x over 3x. Limit 1 minus cosine x over x is 0. Then 1 over 3 times 0. Let me solve it here. 1 over 3 outside the limit. X approach 0. 1 minus cosine x over x equal to 1 over 3 times 0 equal to 0. Choice B. 60. Limit x approach 0 to 1 minus cosine 3x over x when x approach to 0. The answer is 0. The coefficient here is not affected by this limit. Whatever coefficient be, the answer of this limit is 0. Question number 61. Find the limit when x approaches to 0 to 2x plus sine x over x. We apply the rule of trigonometric function. This limit will be 2 coefficient of x here plus coefficient of x inside the sine over coefficient of the x in the denominator equal 3. Choice D. 62. Limit x approach to 0 to 2x plus sine 3x over 3x minus sine 2x. Also apply the rules of trigonometric function. This limit will be coefficient of x here plus coefficient of x inside the sine over 3 minus 2 equal to 5 over 1 equal to 5. Choice D. Question number 63. Limit cosine x tan x over x. Rewrite this limit as x approach 0, cosine x, sine x over cosine x over x. Cosine x with cosine x, then limit sine x over x when x approach 0 equal 1. Choice C. Number 64. Limit x approach to 0 for 3x plus sine 3x over 2x minus sine 4x equal to 3 coefficient of x plus 3 coefficient of x inside the sine over 2 coefficient of x minus 4 coefficient of x inside the sine equal to 9 over equal to 6 over negative 2 equal to negative 3. Choice D. Number 65. Limit x approach to 0 x sine 2x over sine 4x minus 2x equal to limit x approach 0. Rewrite this function as negative 2x plus sine 4x equal to 1 plus 2 over negative 2 plus 4 equal to 3 over 2. Choice C. Question number 66. Limit x approach to 0 to 3 minus 3 cosine x over 3x minus sine x equal to limit x approach 0. Divide the numerator and denominator by x, 3, and factorize the numerator by 3, 1 minus cosine x over 3x over x minus sine x over x equal to 3 limit x approach 0 for 1 minus cosine x over x. As you know, this limit is 0 over 3x over x, 3 minus limit sine x over x when x approach 0 equal to 3 times 0, 0 over 3 minus 1, 2 equal 0. Choice B. Question number 67. Limit x approach to 0 for 4 minus 4 cosine 2x over 5x. This limit will be limit x approach 0 factorized by 4, 1 minus cosine 2x over 5x. Multiply by 2 and divide by 2 equal to limit x approach 0, 4 times 2 bracket 1 minus cosine 2x over 5 times 2x. We multiply by 2 and divide by 2. This limit 1 minus cosine 2x over 2x when x approach to 0 is 0. 0 times 8 over 5, the answer is 0. We can write 8 over 5 here, then 0 times 8 over 5, 0. 68, limit x approach 0 to for cosine 4x tan 8x over 2x. This limit will be limit x approach 0 for cosine 4x times limit x approach 0 for tan 8x over 2x. Multiply the second limit by 4 and divide by 4. Then this limit will be 1. Limit x approach 0 tan ax over 8x is 1. 1 times 4 is 4 times limit cosine 4x when x approach to 0 cosine 0 1. The answer is 4. Choice C. 69, limit x approach 0 for 3 minus 3 cosine x over cosine x tan x equal to limit x approach 0, divide the numerator and denominator by x and factorize these two term by 3. 1 minus cosine x over x over cosine x. Rewrite tan x as sine x over cosine x and divide all by x equal to cosine x with cosine x. The limit will be 3 limit x approach 0 for 1 minus cosine x over x over limit x approach 0 for sine x over x. This limit is 1. This limit is 0. 3 times 0, 0 over 1, 0. The right choice is A. Question number 70. Find the limit when x approach to 0 for cosine 3x tan 2x over x. Rewrite this limit as limit x approach to 0 for cosine 3x times limit x approach 0 for tan 2x over x. Multiply the second limit by 2 and divide by 2. This limit is 1. 1 times cosine 3x when x approach to 0 cosine 0. 2 times cosine 0 1. 2 times 1 2. The right choice is B. 71. Find the limit when x approach to 0 for x minus x cosine 7x over x equal to limit x approach 0 factorized by x 1 minus cosine 7x over x. Multiply this limit by 7 and divide by 7. Then the limit will be 1 minus cosine 7x over 7x when x approach to 0 is 0. 0 times, let me rewrite it as limit 7x when x approach 0 times limit x approach 0 for 1 minus cosine 7x over 7x equal to 0 times 0 equal to 0. The right choice is 0. Question number 72. Find the limit when x approaches to 0 to 2x minus 3 tan x over 5x. This limit will be limit x approach 0 for 2x over 5x minus limit x approach 0 for 3 tan x over 5x. Take 3 over 5 outside the limit since it is constant. Limit x approach to 0 to tan x over x is 1. Reduce x with x, 2 over 5. The answer is 2 over 5 minus 3 over 5 equal to negative 1 over 5. Choice D. Question number 73, which is false. Limit absolute value x over x when x approach to 0 from left equal negative 1. From left, it is true since absolute value x equal x when x greater than or equal 0, negative x when x less than 0. Then from left, it means x less than 0. I substitute every absolute value x with negative x. Then the limit will be limit x approach 0 from left to negative x over x. It is negative 1. It is true. Limit sine x over x when x approach to pi equal 1. It is false. Since limit sine x over x when x approach to 0, it is 1. So the right choice is B. Let me complete. Limit square root x when x approach to a quarter, 0.25, it is 1/2 since square root 1 over 4 equal 1 over 2. Limit square root x when x approach to 0 is 0. Square root 0 is 0. It is also true. The right choice is B. 74, which is false of the following for the following statements. Limit x square root x plus 1 over x minus 4 when x approach to 3. Substitute directly 3 plus 1 for square root 1, 2 over 3 minus 4, negative 1. The answer is negative 2. It is true. Limit tan square x over x when x approach to 0 is 0. It is true also. Limit 3 times 1 minus cosine x over x equal 3. It is false since the limit when x approach to 0 to 1 minus cosine x over x is 0, and I take this 3 outside the limit, then 3 times 0, it is 0, not a 3. So this is wrong. Limit x square when x approach to negative infinity is infinity. It is true since the behavior negative infinity square, it is infinity. So the right choice is C. Question number 75, which of the following is true? Limit cosine 3x when x approach to pi, it is 3 pi. Yes, it is 3 pi, but it is also, we must find the value of 3 pi is negative 1. So this is wrong. Limit tan square x over x when x approach to 0 is 0. It is true. This is the right choice. Let me complete. Limit x approach to 3 for square root x minus 4 over x plus 1 is 2. It is wrong since 3 minus 4 is square root negative 1. It is undefined over 4. It is undefined term. Therefore, this is wrong and this is wrong. For the last one, limit x over x cubed plus 2 is 3 over 8. It is not a 3 over 8, it's 3 over 3 power 3, 27 plus 2, 29. It is 29, 3 over 29. So this is also wrong. The right choice is B. Question number 67. If f of x equal x power 2 minus 3, find the limit when x approach to 1. 1 square minus 3, it is negative 2. The right choice. It is direct. Question number 77, which is false for the function f of x equal to 2x when x between 0 and 1, 1 when x equal 1, 3 minus x when x between 1 and 2. Limit f of x when x approach to 1 not equal to f of 1. Let us see. F of 1 when x equal 1, the value is f of it is 1, f of 1. Let us see limit when x approach to 1. Since 1 appear 2 when x less than and greater than, I should find it from left and from right. From left, I substitute in this segment, it is 2. Limit x approach to 1 from left for f of x equal to limit 2x when x approach to 1 from left equal to 2 times 1 equal to 2. And from right, limit x approach 1 from right for f of x equal to limit x approach from right for 3 minus x equal 3 minus 1 equal to 2. Then the limit not equal. It is true. It is not false. Let us see. Limit f of x when x approach to 0 from right. 0 from right, it means x greater than 0. I substitute here. Then the limit will be 2x when x approach 0. Then 2 times 0 is 0. Then this statement is also true. Limit f of x when x approach to 2 from left is 1. 2 from left. This appear here to 1 time. When x less than 2, then I substitute here. 3 minus 2, 1. It is also true. F of 1 not equal to 1. It is wrong. F of 1 is 1. When x equal 1, f of x is 1. It is true. So this statement is false. The right choice is D. Question number 79, which is false for this function. Limit f of x exists when x approach to 1. When x approach to 1, from left, 2 times 1, it is 2. From right, negative 1 time plus a 3, it is also true. It is also true, so this statement is true. It is not the right choice. Limit f of x exists when x approach to 2 from left. 2 from left, it means x less than 2. I substitute here. Negative 2 plus a 3, 1, it is exists. So this statement is also true. Limit f of x exists when x approach to 0 from right. 0 from right, I substitute here. 2 times 0, 0 exists, also is true. F of 1, it is undefined, it is false. Since f of 1, it is 4, it is defined. When x is 1, f of x is 4, the right choice is D. Which is false for this function. H of O of 4 not equal to the limit of h of x when x approach to 4. When x approach to 4, let me find h of 4. H of 4 equal to, when x equal 4, h of 4 is 3. Let me find the limit when x approach to 4 from left. From left, it means when x less than 4, I substitute here. 2 times 4, 8. 8 minus 5, 3. Let me find limit when x approach to 4 from right. From right, it means when x greater than 4. Negative 4 plus 7, it is 3. It is also 3. Then h of 4, it is equal to limit of 4. This statement is false. Let me check the second one. Limit h of x when x approach to 6 from right. 6 from right, it means when x greater than 6, 6 plus 2, 8, it is true. Limit h of x when x approach to 0 from right. 0 from right when x greater than 0. 2 times 0, 0 minus 5, it is minus 5, it is true. H of 6 is 1. 6 belong to this interval, then I substitute here, negative 6 plus 7, it is 1, it's also true. The right choice is A. 84, find the limit. If we substitute directly, 1 plus 3, 4 square root 4, 2, 2 minus 2, 0, the denominator will be 0. I'll multiply by the conjugate of the denominator. 1 plus x plus 2, square root 1 plus x plus 2. The answer is limit x approach 3, 4. 2, take it as a factor, common factor, x minus 3 times square root 1 plus x plus 2 over square root times square root 1 plus x, negative 2 times positive 2, negative 4. Then the result will be x approach 3, 4. 2 times x minus 3 times square root 1 plus x plus 2 over x minus 3. 1 minus 4 minus 3. Reduce x minus 3 with x minus 3. Substitute every x with 3. The answer will be 2 times 1 plus 3, 4. Square root 4, 2. 2 plus 2, 4. The answer is 8. Question number 85. Find the limit when x approaches to 0 for x over square root x plus 1 minus 1. 0 plus 1, 1 square root 1, 1 minus 1, 0. Multiply by the conjugate of the denominator, x plus 1 plus 1, square root x plus 1 plus 1. Then limit x approach 0 for x times square root x plus 1 plus 1 over square root times square root x plus 1, negative 1 times negative 1 is negative 1. Negative 1 with positive 1, x with x, substitute every x with 0, square root 1 plus 1, 2. The right choice is D. The last question in this set, 86. Find the limit when x approaches to 1 for f of x minus 3 g of x. If we find it separately, then 3 over 1 minus 1, 0. 1 over 1 minus 1, also 0. Then I'll try to find it together. X approach 1 for f of x is 3 over x minus 1 minus 3 times g of x, x over x minus 1. Then the limit when x approach to 1, x minus 1 common denominator. The numerator will be 3 minus 3x equal to limit x approach 1, factorize the numerator by negative 3, then it will be x minus 1 over x minus 1. Reduce x minus 1 with x minus 1, the result will be negative 3. See you next lesson.